title of my talk is Lipidomics of Retinoblastoma. Retinoblastoma, mostly known as RB, is an eye cancer, and it's mostly prevalent in children below 5 years of age. And Asia and Africa have reported major cases, and annually there are 8,000 new cases worldwide. And this is completely curable, but only if diagnosed in early stages. If it is diagnosed in very late stages like E-grade and D-grade tumors, enucleation is necessary. This is the background. As you all know, as you all see the anatomy, and as you all know, this is the anatomy of the eye. Let me take the pen. So this is the cornea, the front portion of the eye, which is attached to aqueous humor, and behind the lens, this is vitreous humor, and here, this is the cancer starts at the back of the eye, which is associated with the vitreous humor. And this is our methodology. Here, RB occurs mainly due to the inactivation of tumor suppressor gene RB1. RB protein is identified as a target for ceramide to cause cell death. And in retinoblastoma, RB gene is mutated. So we thought a lipidomic profiling can give as a nice way to understand retinoblastoma. So we have taken two cancer cell lines. One is WERI-Rbl and another one is NCC RBC51 and a control cell line MIO-Ml. NCC RBC51 is a established cell line from a metastatic cancer site, and WERI-Rbl is established from enucleated RB tumor, and MIO-Ml is a retinal cell line. This is lipid extraction protocol we followed. Lipids are extracted with water, methanol, chloroform in 3:4:8 ratio. And we have used Master-Nagel C18 or PLC, and we have used isopropyl alcohol as the main element in our mobile phase system. We used a flow of 250 microliters. The column was kept at 30 degrees centigrade, and Q-Exactive Plus instrument was used in this study for high resolution and accurate mass identification. We have identified 4,898 metabolomic features, but only 786 features we could annotate using public databases. And among them, 88 metabolites were upregulated and 147 metabolites were downregulated with log2 fold change greater than 2 and p-value 0.05. And even among them also, we have done manual verification to match the MSMS spectra with the accurate mass identified, and we could confirm 45 dysregulated entities. This is the phospholipid dysregulation. As you can see, MIO-M has all the phospholipids normal level in low abundance, but both WERI NCC with NCC cell line, all these are upregulated. All phospholipids are regulated. In these phospholipids, we could see lysophospholipids with 24:0, 24:1, and also diacyl phosphocholine, and majorly plasmalogens. We could see plasmalogen phosphorethanolamines and also plasmalogen phosphorylcholines. All are upregulated. Most of the plasmalogens are upregulated in NCC and WERI also. So phospholipids are dysregulated in RB. And we could also see a lot of sphingolipids dysregulated. As you can see, sphingomyelin, which is sphingomyelin is dysregulated, and ceramide, which is a D18:0 is a dihydro variety of ceramide, and also D18:1 is the normal ceramide. And many of them are dysregulated with a very reasonable fold change. And glycosphingolipids, which are glycated version of sphingolipid, are also dysregulated. Here we are showing at least 3 glycosphingolipids, which are GM3, this is D18-124:1 chain, and GM3, D18-116 chain, and GA1. See, both GM3 are gangliosides. Gangliosides means the ceramide will have at least one sialic acid, and this also we could we have to manually verify to confirm the compound. As for these compounds, authentic compounds are very rare and very costly, so we could do manual verification. As you can see, sialic acid is lost with a 291 Daltons, and then one sugar loss and one more sugar loss. So there are at least 3 sugars and one is a sialic acid. So like that, we identified gangliosides, and in GA1, GA1 does not have sialic acid. So all these 3 are down-regulated. Blue is control cell line. So and red and yellow are cancer cell lines, and in both of the cancer cell lines, the glycosphingolipids are dysregulated, down-regulated. This is the heat map. In the heat map, we are giving all the major markers, all the major metabolites from ceramide pathway or sphingolipid pathway, ceramides, gangliosides, hexosyl ceramides, and sphingomyelins. And the important thing is, all in the retinal cell line, all are upregulated. Mostly these are upregulated, but in the cancer cell lines, these are downregulated. All the ceramides are downregulated. As it's a known fact that ceramide is anti-proliferative. Ceramide is anti-proliferative, and so maybe that is the reason the cancer cells didn't like it. But if you see the glycosphingolipid, hexosyl ceramide is upregulated. This is an interesting feature. We could see that hexosyl ceramide is upregulated in NCC and WERI also. And we could see hexosyl ceramide is highly upregulated compared to control and WERI. This is very much highly upregulated. We think this is a potential marker while screening, and a potential marker to study and understand retinoblastoma in a deeper way. And we made a Boolean expression. We have taken Boolean implication analysis of all the genes in retinoblastoma, taking at least 100 gene expression data sets that are publicly available. And when we draw the gene expression data of KDSR gene, which is an important gene in the sphingolipid biosynthetic pathway, we could understand in the retina, in the healthy retina, this is highly upregulated. But RB type 1, which is non-invasive RB, it is somewhat low, but in the invasive RB type, it is very much downregulated. Similarly, ST3 GAL5 gene is also very much high in the control retina, but it is severely downregulated in the invasive RB type. So when we think why this hello, when we think when we think why this sphingolipid pathway is highly downregulated, and only hexosyl ceramide is upregulated, we could think of the cell type itself. We know WERI is a non-resistant cell line, and NCC is a resistant cell line. So to prove this, NEMA-related kinase NEK is a marker for drug resistance. So by qPCR, we did the gene expression study for the NEK2 in both tumor and cells, and taking WERI as the control. Here control is WERI. So compared to control, it is very highly expressed in the tumor and and here compared to WERI, it's very highly expressed in NCC. So a drug resistance marker is very highly expressed in RB, in NCC. And we have also done this study that there is a series C25 inhibitor. When we give this drug to the mouse xenografts, this reduces the tumor burden. This reduces the tumor burden, and tumor is reduced. At a normal dose, tumor is less, but at a higher dose, tumor is reduced. So the series C25 inhibitor can decrease the tumor size. So we thought of using this drug on the cancer cells. But when the cells are exposed to this drug, control, which is we used this drug and performed NAK2 expression. Control, which is very cell line, has very less NAK2, but CDC inhibition, upon the CDC inhibition, still NCC cell lines, there is no change in the NAK2 expression. Then we move to fluorescence. In the figure, you can see the stained NAK2 protein in NCC and in WERI, and also stained cells, stained nucleus. So here in the bottom part, the presence of NAK2 in the nucleus is known to be more problematic and deadly to the cell rather than its cytosolic presence. But in this figure, as you can see, the protein is cytosolic, and in the NCC it is in the nucleus. And upon the CDC inhibition also, it didn't change. So we confirm that the drug resistance nature, the NCC cell line has drug resistance nature. So then how this drug resistance is implied in the lipid profile and in the ceramide pathway. To study this, we selected some genes from the ceramide pathway. Ceramide pathway is briefly like this. The palmitoyl CoA, which contains 16 carbons, reacts with serine, and makes a C18 chain. But the amine group in the serine will be added. The amine group will be added, and then the carbonyl group will be intact. So it will be a 3-dihydroceramides. Upon the KDSR gene, upon the action of KDSR protein, the ketone group will be reduced. So it will be a saturated chain now, sphingosine. Upon the action of ceramide transferase, up to now, it is only amine. To this amine, a fatty acid will be added. Then the amine will be linked to a fatty acyl chain, so making it as a dihydroceramide. Still, the backbone, the ceramide backbone, which is the sphingosine backbone, it is still saturated. So upon the action of DEGS1, a double bond will be inserted and it becomes ceramide. Now, upon the action of EGCG, it will be glycated to form hexosyl ceramide or glucosyl ceramide. So all these genes, we designed the primers and we studied the qPCR, and to our surprise, compared to control, all genes are the gene expression is downregulated. So then how the hexosyl ceramide is very much upregulated. So it is not due to the biosynthesis of that particular protein, UGCG protein or glycosyl ceramide. The biosynthesis is not upregulated, but maybe it is due to the degradation of the glycosyl ceramide once formed. The GBA gene is the GBA protein is required for the degradation of glycosyl ceramide. Maybe if it is defined, the glycosyl ceramide is upregulated, and this kind of accumulation of glycosyl ceramide is already reported in many other cancers. Like those people who failed chemotherapy, they're all known to have upregulated hexosyl ceramide. And in multi-drug resistant cancer cells from different tissues of origin, in that context also, it is observed the upregulation of glycosyl ceramide. And oxaliplatin resistant colorectal cancer cells have seen upregulation of hexosyl ceramide. And drug resistant ovarian cancer cells also saw upregulation of hexosyl ceramide. So if we study more on the ceramide pathway, maybe we can identify more targets, and we can understand RB in a better way. These are all the people who contributed to this work. Omkar has done the analysis, manuscript writing. Shruti has done the analysis, and all other people are my collaborators from Shankar Netralaya. Bhavani and Amit has done the cellular assays like protein expression, gene expression, and qPCR study. And I'm very much thankful to Dr. KK for providing us the cell lines, and Dr. Narayanan and Dr. Sailaja were extremely helpful and motivating in the entire project. I thank you all.